So the goal today was to map the internals and the external of the pumping station. For this we used georeferenced reflected targets in the area. Then we also georeferenced them with a GPS. And then we flew the drone around the targets, indoors and outdoors, to map the asset. The GPS itself is connected to Swisspost, which is an N-trip service, which provides a correction network to the GPS. So in this case, we can get the accuracy to within roughly around 10 millimeters. We're using the reflected targets as it can be seen within Faro Connect itself. And in Faro, there is an algorithm that will self-detect the targets, look at the registered points that we collected with GPS, and automatically georeference the data together. Capture the targets on the outdoor flight and then also on the indoor flight as well. However, if you're not able to capture the targets all the time, you can always merge different flights together in Faro Connect. I usually ask for some sort of plans or drawings of the original structure itself to understand a bit more about the asset itself, also the amount of detail inside, whether it's an empty room or if it's a type of room with lots of pumps and pipes in this case. From then there we estimate exactly how long it's going to take, how many flights, etc. So in this case today it took roughly around 3 flights to complete the outdoor and the indoor section as well. Usually when we arrive to the site, we do a quick recce of the site itself to understand the complexity of the site. Here obviously we're in a residential area as well, so we need to be careful of any of the public passing by, the areas that we're flying, especially in the outdoor section. From there then we look at the best place to place the targets itself. In this case is more or less outside the front door of the building where we place the targets. And also we have to keep in mind as well that we have a clear view of the sky for the GPS, so we can get good accuracy on the GPS. So after the scan then we download all the data into Inspector. From then there we export the .geosam file, bring that into Faro Connect, and from then there we process the raw data from the drone. 2 to 3 hours of processing in total for all the flight data that we captured today. From then there we bring that into oil&gas recap, convert the exported LAS file that we get from all the combined LiDAR point cloud data in Faro into an RCP file. So an RCP file is a register file that Revit can then read the point cloud data itself. So from then there we go from recap into Revit, and from then there the conversion begins from the point cloud data into the BIM model itself. So in this case it's a newly built building, and the goal of the data is to do a clash detection model. So that means that they already have an AutoCAD Revit model from the design phase of the building. We flew the entire building, processed the model, and create another Revit model of the actual as-built of the building itself, and then from then there they can do a comparison between the design model that they had originally designed and the as-built model that we captured with the drone data.